Problems on irrotational vector fields and finding the scalar potential phi. Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. As we are moving on with vector differentiation, so in today's video, I will be solving some major important questions on irrotational vector fields and finding the scalar function phi. Note that these problems are very important as they can be asked in a final examination for 6 to 7 marks. So, please watch the video carefully till the end, practice with me so that you do not lose any marks in the examination if it is been asked. My dear friends, the main motive of starting this channel is to help the engineering students who find mathematics very difficult and fail to understand it, to make it in a very easy way, so that you understand it and get good marks in the examination and do not get any back. So, if you are watching this, then please do not keep it to yourself, share with your friends, the co-students as much as possible, so that each and every student of engineering gets benefited from this ultimate resource and they achieve their goals. And if you are new to this channel, then please hit the subscribe button and ring the bell icon so that you never miss any further videos on engineering mathematics. Now, grab your notebooks, grab your pens, and without wasting time, let us start doing the maths. See, the problem here is, show that f vector is equal to y plus z into I plus z plus x into j plus x plus y into k is irrotational. Also find scalar function such that del phi is equal to f. So, now see, as we have been through previous problems and the theory, you know the condition for a vector field to be irrotational. That is what? For a vector field to be irrotational, the condition is curl of f or del cross f is equal to 0. If that condition is satisfied, then the vector field is irrotational. Okay. So, write it here. So, for irrotational, the condition is curl of f or del cross f is equal to 0. So, for this given vector f, we have to prove this condition, then only it is irrotational. So, let us do it now. So, what does it mean? Del cross f is nothing but determinant I j k dou by dou x, dou by dou y, dou by dou z, okay, and write the all components of I j k here. So, first one here will come y plus z, j is z plus x, and below dou by dou z we have x plus y. Fine. Now, I will solve it here only. Let us solve it determinant here, plus minus plus, as you all know. So, first always I into C. What is the process here? I will show you once again. It is very easy. When I take this I plus sign, leave this column, leave this row. So, dou by dou y of x plus y minus dou by dou z of x z plus x minus j into. So, what is that? Leave this column and the row. So, I had dou by dou x of x plus y minus dou by dou z of y plus z. Clear? Next, last one is plus k. So, plus k into. So, we leave this column, leave this row. So, what remains? Dou by dou x of z plus x minus dou by dou y of y plus z. Okay. So, let us solve this and see what answer we get. Now, differentiate the you need to partially differentiate properly. So, see, I into dou by dou y of, see here we are partially differentiation, you have to do it correctly. So, practice it well. This is a very simple one. Dou by dou y means you are partially differentiating with respect to y. Yes, there is no y, so it is constant, differentiation constant is 0. So, y, there is y is 1 minus dou by dou z, see z is there, difference z is 1 minus j into, again dou by dou y of with respect to y, so x is 0, y is 1 minus again dou by dou z of y is 0, z is 1 plus k into, finally dou by dou x of z is 0, x is 1, dou by dou y again y is 1. So, now if you see here what happens, this all cancels, it cancels. Therefore, what is the answer now? We get it as 0. The answer is coming as 0. That's it. So it's already proved, since del cross f of curl of S is 0, therefore you can write it as what? F vector is irrotational. That's it. So this is the answer. Okay. So we have already proved that del cross f is equal to 0. So f vector is what? Irrotational. Now the next thing is to find the scalar function phi such that del phi is equal to x. See, if you go to the first video, I have given the theory. Even if they ask directly find a scalar function, okay, they will not give you del phi is equal to f. You need to take, to find any scalar function, you need to always use the formula del phi is equal to f always. Okay, so I write it here. So to find phi, to find scalar function phi. So what's the formula we use? We use del phi is equal to f vector. So now what is del phi? As you know, del means dou by dou x of I plus dou by dou of j plus dou by dou z of k, into phi means dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k. Fine. So write it here. So let's write the equation here. So we have this as dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k is equal to, what is the f vector? F vector is the question here. So we have y plus z into I plus z plus x into j plus we have x plus y into k. That's it. Fine. Now, what are you going to do? We are going to just compare both the LHS and RHS. What are you going to compare? See here, so see clearly, there is I here, there is I here, j, j, k, k. So what are you going to do? The equation is equal to equalize. So we are going to compare i's, the j's and the k. Okay. So if you compare it, what we get? We get dou phi by dou x is equal to, so what is dou phi by dou x? See, I. So dou phi by dou x is equal to y plus z. Therefore, phi is integration of y plus z, and see dx, this dou is turned. So when dou enters integration, it becomes dx, differentiation. So simple, dou x, so this will be what? Dx. Fine. Now here see, you are integrating with respect to what? Dx. So as you know, integration of 1 dx is also x. Similarly, integration of 1 dy is also y. Similarly, integration of 1 dz is also z, because integration of 1 exists. Because as we have been solving this in other units also, I keep on repeating. See, differentiation of x is 1, so integration of 1 is x. So understand, we are partially integrating here. That means, see, understand this carefully. Integration of y plus z. So y is as it is. So y as it is into 1 exist. Integration of 1 is what? Dx into x plus z as it is, integration of 1 is x. And remember one thing, you have to write it compulsory. Since we are integrating here with respect to dx, see, we are partially integrating, so x, y, z. When we integrate with respect to x, what is the constants remaining? Y and z. That means the constant will be f of y comma z. That's it. You have to show it. That's all. Next one, dou phi by dou y is equal to z plus x. Fine. Therefore, we have phi is equal to integration of z plus x. There is what? Dou y. So this becomes dy. Now again, we are integrating to y. See, don't make 0, because integration 1 exists. Be careful here. So phi is equal to z as it is, integration 1 is y. If there is y term, then obviously integrate. But see, simple question, z as it is, integration 1 is with respect to device y, again plus x as it is, integration 1 device y, plus, since I am integrating here with respect to y, x, y, z, who remains? x, y, z. Why I am doing so? X and z remains. So the constant is f of x comma z. And finally, the last we have dou phi by dou z. We are comparing k with k. So we get x plus y. So phi will be integration of x plus y dz. Fine. Dou enters integration become dz. Now here we are integrating to dz. So phi will be equal to, now x as d is, there is no z terms here. Integration 1 is z plus y as it is z, and lastly x over, so we are integrating with respect to z. So z is, we are doing, who remains x and y. So the constant function is x comma y. That implies phi is equal to, now see here, I am writing a function. See, in function what happens, f plus x overlaps on x to become x only. I mean to say, we have three functions, phi, phi, phi. You add all these things. See, we have three functions here. One is this one is this phi, and one is this phi. So when I add all these things here, understand it, x, if there is x in one, other again x is there, so take it only once. If the functions, if the functions are repeating here, always take it once. Okay, so here see, I write here yz plus xz, I take this as xy plus zx, I take xz, fine, again plus zy, and simply adding them. See, I add it yx plus zx, that is xy plus z is same as it is, plus zx zy plus xy. See, xy is there, so don't take it, as simple as that. Getting your point? So if it is repeating, the values are repeating twice, take it only twice or thrice, take it only once, that's all. So xy plus zx plus zy, xy is there, leave it, plus zx is already there, see, it's there only once, yz is also there, that's it. So the flux, that is, sorry, that is, therefore the scalar potential phi for this function f is equal to xy plus xz plus zy. That's it, as simple as that. See, these questions they ask for 6 to 7 marks. So please understand this clearly how it is done and practice them so that you become well versed in solving it. That's all. See, the next problem which we are solving here is, find the constants a and b such that f vector is equal to ax y plus z cube into I plus 3x square minus z into j plus bx z square minus y into k is irrotational. Also find a scalar function such that del phi is equal to f. Note that, go back to the theory which I given. For any vector field to be irrotational, del cross f is equal to 0. Okay. See, the question need not be, as mentioned, the question need not be irrotational or scalar function. As you know, when del cross f is equal to 0, the vector field is said to be irrotational, conservative field or potential field, and the phi is called as scalar function or scalar potential. So in the question, instead of irrotational, they can be conservative field or potential field, and instead of scalar function phi, they can also mention scalar potential. So everything is same. Okay, so let's start this question now. See, in this question you have to find a and b, and again already it is what? Irrotational. So irrotational means what? They given already irrotational, that means del cross f is equal to 0. So we have irrotational means del cross f is equal to what? 0. Fine. So let's apply this condition here, put equal to 0 and find the value of a, b for which it makes the curl 0. That's it. Fine. So let's do it here. So we have del cross f equals I j k. So for we have below this dou by dou x, dou by dou y and dou by dou z. Below dou by dou x, the I component, that is axy plus z cube. Then below dou by dou y, it is 3x square minus z, and lastly bx square minus y is equal to 0. Fine. So let's solve this determinant now. That implies, so this will be as usual I plus minus and plus. So we have always plus I into, see, I leave this column, leave this row, dou by dou I of. Be careful while solving determinant here, dou by dou I of and doing partial differentiation, otherwise you lose marks. See it carefully, dou by dou I of B x z square minus y minus dou by dou z of 3x square minus z minus, always as I told, j term is always minus j into, so we have leave this column, leave this row, dou by dou x of dx z square minus y minus, fine, dou by dou z of axy plus z cube. Okay, then finally plus k into, leave this column, leave this row, dou by dou x of 3x square minus z, fine, minus dou by dou I of minus dou by dou I of axy plus z cube will be equal to 0, since the condition is given to be what? Irrotational. So it's given irrotational, so it is what? 0. Now let's partially differentiate this and see what we get. Is equal to I into, see, dou by dou y means we are partially differentiating here with respect to only y, only y. Bx z square, no y term, so 0, differentiation of constant is 0, minus differentiation y is minus 1, minus dou by dou z, again 3x square, no z terms, differentiation z is there, minus z is minus 1, so minus minus become plus 1, minus j into, so this is what? Minus j into dou by dou x. See here you are differentiating only with respect to what? X. So bz square as it is, differentiation x is 1 minus y is 0, minus dou by dou z of axy, no z term, partially differentiate only with respect to z. So differentiation z cube is nothing but minus 3 z square plus k into dou by dou x with respect to x, 3x square, differentiation of 3x square is 6x minus dou by dou y, ax, y is 1, z is 0 is equal to 0. Now this will be, that implies minus j into b z square minus 3z square plus k into 6x minus ax equals to 0. See, very easy. What are the values of b and a which I put here makes this whole thing 0. Very simple. See, bz square minus 3z square. So bz square is equal to 3z square. What is b is equal to 3? That is b is equal to 3 and 6x minus ax. 6x minus 6x is 0. So a is equal to 6. That's it. Just by observing we can tell the value. So the constants a and b are nothing but what? A is equal to 6 and b is equal to 3. That's it. Understood? This is how we find a constant a and b. Now the next part is find a scalar function such that del phi is equal to f. So putting a as 6 and b as 3, I will write this equation here. So we have f vector is equal to, what is that? A is 6 xy plus z cube into I, fine, and plus 3x square minus z into j plus b is 3x z square minus y into k. This is my vector. Now the condition to find a scalar function is del phi is equal to f. If they don't give, you have to memorize it. Always the condition to find the scalar function phi is, or scalar potential phi is, del phi is equal to f. So we have to find scalar function phi. What's the condition? Del phi equals to f vector. So now let's use this condition. So as we know, del phi is always, it will be dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k equals f vector. What is f vector? We have 6xy plus z cube into I plus 3x square minus z into j plus 3xz square minus y into k. So now let's compare, since its equation is equal to here. So let's compare both the LHS and the RHS. So what is there to compare? See, you have to compare I with i's, j with j, and k with k. That's all. So if you compare that, we are going to get, that implies, see, I means dou phi by dou x, dou phi by dou x, dou phi by dou x will be equal to 6xy plus z cube. Fine. Therefore, see, dou phi by dou x will be equal to 6xy plus z cube. So what is phi? If left side is differentiation, right side is the thing. So when I remove the left differentiation, right side becomes integration. As simple as that. So we have phi will be equal to integration of 6xy plus z cube, and dou goes to integrate to become, when dou enters integration becomes dx. And here see, you are integrating with the x. See, you know that integration of, I will write integration here. See, integration of x raised to n dx is equal to x raised to n plus 1 by n plus 1. Is a simple formula in integration. There will be a simple integration here. So since we are integrating with x here, see, phi is equal to 6 as it is. See, you are integrating only with respect to x here. Okay. So integration x is nothing but x square by 2 into y plus z cube as it is. Note that you are integrating with respect to x. So integration of 1 dx is x into x, and since we are integrating here with respect to x, y, z, x is integrated, the constants remaining are y and z. So you have to clearly write here the function f of y comma z. That means we have here phi is equal to, so 2 and the 2 3s are 3 x square y plus x z cube plus f of y comma z. So first value of phi. The next one is dou phi by dou y is equal to, what is that? 3x square minus z. Therefore phi is equal to integration of 3x square minus z with respect to dy. Now here we are integrating with respect to y. Okay, so that will be now phi is equal to 3x square as it is, integration of 1 dy is y, minus z as it is, integration of 1 is y, and since we are integrating with respect to y here, x, y, z, y, the constants remaining are x and z. So we write plus f of x comma z, and finally we have dou phi by dou z is equal to 3 x z square minus y. So we have phi is equal to integration of 3x z square minus y dz. That is phi is equal to, since we are integrating with respect to z here, z square is there. So 3x as it is, integration of z square is z cube by 3y, because integration x raised to n dx is x to n plus 1 by n plus 1. So integration of z square will be z raised to 2 plus 1 3 upon 2 plus 1 3. So z cube upon 3 minus y into integration 1 is 1 with respect to dz is z only, and the constants are f of x comma y. Why? Because dz, what remains? X and y. So 3 3 cancels here. So phi will be equal to x z cube minus yz plus f of x comma y. So we have all this fluxes here. So we have three phis here, 3 scalar potentials here. Now we have to add them together to make a single potential. And what did I tell you? Always when functions add together, function plus function becomes single function. That is, when we have this, when there are more than 2 times a value is repeated, take it only once. So first starting with, see here, phi is equal to, so we can write, therefore scalar potential total phi is equal to, so what is that? See here, 3x square y, take it, plus x at cube also you take it. Now see, plus again 3x square y repeating, so take it only once, don't take it, plus minus zy is, okay, take it, x at cube. See, what is that? X at cube is there already, so don't take it. If repeating, don't take it. That's it. Minus y there already. So done. So understood the concept. See, 3x square y, 3x repeating. Take it only. What you repeat, take it only once. That's it. And simply keep on adding it. So from this adding all these things total phi, we find the total scalar potential as phi is equal to 3x square y plus x cube minus zy. That's the answer. So I hope you understood how to solve problems of such type in a very easy way. Okay, see, there is little bit of confusion here. Some partial differential work is there, some integration work is there. So don't get confused. Watch the video as many times as possible and practice it. If you do it 2 to 3 times, practice it, then definitely you are going to get how to solve these problems correctly. Okay, so that's all for today. If you like the way I teach, and if you have any other suggestions, please drop the comment below, share with your friends as much as possible, and don't forget to subscribe. So see you in the next video. Be curious, happy learning. Bye.